Consider the next word problem regarding maxima and minima. Perimeter of a triangle is 10 centimeter. If one of the side is 4 centimeter, find two sides, remaining two sides, so that area of the triangle will be maximum. What is given? Perimeter of the triangle is given. Perimeter is 10 centimeter and one of the side is given 4 centimeter. Okay, so consider the given things first of all. Perimeter 10 centimeter, one of the side is 4 centimeter. We know for area of the triangle there are some formulae, out of which we have to use Hero's formula here because the three sides perimeter are known. So which formula we will use? That formula, area of the triangle is equal to square root of s into s minus a, s minus b into s minus c. So for that the perimeter is given. Using perimeter we will find s. Here perimeter is 10. So s semi-perimeter is equal to perimeter total 10 divided by 2, that is equals to 5 centimeter. Right? S is equal to 5 centimeter, semi-perimeter is equal to, then one of the side is given 4 centimeter. So let A, B and C be the sides of the triangle. So one of the side is given. Let that A is equal to 4. A is equal to 4. One of the side, remaining two sides B, C and total perimeter is 10 centimeter. Therefore, yes, 4 plus B plus C is equal to 10. This is equal to 10 centimeter. Therefore, B plus C is equal to 10 minus 4, that is equals to 6. Sum of the two remaining sides is equal to 6. Now we have to find the two sides so that area is maximum. The function will be area. Function will be area of that triangle. We will use that formula. Before that, B plus C is equal to 6. We will consider B in terms of C or C in terms of B, so that there will no two different variables. There will be only one variable. We can convert this B in terms of C or C in terms of B. This implies B is equal to 6 minus C. So that my function will be in C only. Right? Look here how it will be. Now area of triangle. What is it? What is the formula? A is equal to, yes, square root of s into s minus a, s minus b, s minus c. Taking square on both sides, area square is equal to, so that this square should not there. Simplified form we will get here by squaring on both sides. Substitute s is equal to 5. Square root will cancel by taking square. 5 into bracket s is equal to 5 minus, what is a is equal to 4 into 5 minus b, what is b is equal to 6 minus c, or we will write it in the next step, into 5 minus c. So this is equal to 5 into 5 minus 4 1, 5 minus b, that is 5 minus 6 minus c. 6 minus c, minus this will be plus, into 5 minus c. So this is equal to 5 minus c, that is 5 minus 6, that is minus 1, minus plus c is there. So 5 into bracket c minus 1, and here it is 5 minus c. This is our function. Let us multiply these two. By multiplying the two, we will get here. Let the function is function is, you may consider this a, b, c, or this c can be taken as x. The function f of, generally we take the function of x. Now here it is not the function of x, it is function of c, remember. So here we will consider f of c is equal to nothing different, just x is replaced by c. The variable x is replaced by c. We will take here c. So the function will be 5 into product of these two brackets will be 5, keep as it is constant, but product of these two, this will be 5c minus c square minus 5 plus c. So yes, opening this bracket, 5c minus multiply by c, c into 5 minus c into c, c square minus 1 into 5 minus 5 minus 1 into minus c plus c. So this is equal to 5 into bracket minus c square 5c plus c, this is equal to plus 6c, and this minus 5. Now take derivative step by step. First of all, differentiate this with respect to c, not with respect to x. Differentiate this function with respect to c. Differentiate with respect to c. So what will you get? F dash of c is equal to 5 constant into bracket derivative of minus c square, that is minus 2 times c, plus derivative of 6c is only 6, right? And derivative of 5, which is constant, will be 0. So derivative of c square with respect to c is 2c, this minus sign carried. 6 times c, derivative of 6 times c with respect to c is equal to 6 only. This is the first order derivative. And again differentiate this with respect to x. Again differentiate with respect to, not x, sorry, with respect to c. So this will be f double dash of c is equal to 5 times constant, coefficient is there, into bracket derivative of minus 2 times of c is nothing but minus 2. 6 is constant, its derivative will be 0, and this value is equal to minus 10, which is already less than 0. So whatever here we get value of c for f dash of c is equal to 0, that value is nothing but maxima. Here look at this, it is linear function, linear polynomial. So there will only one value for c, and that value will be maxima. Why it will be maxima? Because second order derivative is already less than 0. Okay. So consider that turning point. Now for the turning point, f dash of c is equal to 0. Turning point means what? At which the function becomes maximum or it becomes minimum. So it is called as turning point. Increasing, then decreasing. So that turning point is maximum. Decreasing, then increasing. So that turning point is minimum. So here for f dash of c is equal to 0, that is consider this one, 5 into bracket minus 2 times c plus 6 is equal to 0, and hence 5 cancel, minus 2c plus 6 is equal to 0, and therefore here you will get c is equal to 3. Value of c will be 3, and this value will be maxima because second order derivative is less than 0, is maxima. Why it is maxima? Because by second order derivative test, f double dash of c is less than 0 is maxima, because f double dash of c is equal to minus 10, which is less than 0. So we used here second order derivative test. Hence this is maxima, means f of x, our function will be maximum. This function will be maximum if c is equal to 3. So one of the side we get c is equal to 3. I will put this value of c here so that the value of b will be obtained, and therefore b is equal to 6 minus c, that is 6 minus 3, that is equals to 3 again. So these are the values 3, 3 and 4. One of the value is already given. One of the value is already given. So that area of the triangle will be maximum. Hence, write down your final answer. Hence, sides of the triangle are 4, 3, 3 centimeter. So that area will be maximum. Area will maximum. Okay. Look it again. Let us revise it. First of all, perimeter is given. So I will find semi-perimeter. S is equal to, which is required for Hero's formula to find area of the triangle. After finding S, then one of the sides is given 4 centimeter. Remaining two sides, sum of the remaining two sides will be 6 since perimeter is equal to 10. So 10 minus 4, sum of the remaining two sides is 6. Using this one, I will convert the side B in terms of C. It will be B is equal to 6 minus C. After that, area of the triangle, the formula I know using this information. Using this information, the formula is S into S minus A into S minus B into S minus C. S is already obtained, A is given 4 and B in terms of C is there. So I will have the function in terms of C only. Because of this purpose, we convert this B in terms of C. Otherwise what will happen? Here the variable will be B as well as C. B as well as C. And then it is not possible for us to differentiate this. So we should have the function in one variable only, so that we can differentiate this. Okay, so for that purpose we convert this B in terms of C. Here substituting the values, we got the function area squaring this. Why we squared this? Because this square root is quite difficult to differentiate. It will be lengthy to differentiate. So we square this first of all, then we consider that function. The function is considered, square of this one is our function now. Then differentiate this with respect to C because our variable is C. Again differentiate this same process. Then for turning point f dash of C is equal to 0. Substituting this, we find the value of C. This value will be maxima by second order derivative test because our f double dash of C is already less than 0. And then using the value of C here, we got B is equal to 6 minus value of C. So it is equal to 3, and hence the remaining sides of the triangle are 3, 3. So that area of that triangle will be maximum. Okay, let us consider one more example. Consider the next example. An open box with square base has area 192 square centimeter. Has its area 192 square centimeter. Total area of the box is 192 square centimeter. Find its dimensions, means you have to find its length, breadth and height so that its volume will be maximum. Volume of that box will be maximum. So here length, breadth and height, but we know that the box has square base. Now look at this box. Top is open, it is open box. Square base is there, this base is square. So since the base is square, the length and breadth, these two sides, all the four sides will be having same length. Okay, so we will consider the same variable for these two sides, and this is height h of that box. Okay, so let these sides of the base are x centimeter height by usual notation we will consider it as h. So what will be the area of this box? Since the box is open, so no top is there, area will be considered of the base, this side, this side, this side, and the back side also, this side also. So 1, 2, 3, 4 surfaces and base. For base, the base is square, so if we consider x as the side, so x square will be the area of the base, and these 4 are same. These 4 surfaces are same, they will have same area. Why they will have same area? Because our base is square, so this length is same as that of this one and the back one. Okay, so 4 times area of this surface plus area of the base. So let us consider the base with sides x centimeter. Let sides of the base, sides of the square base x centimeter each, since it is square, and height of the box is h centimeter. So x be the side of the base, height of the box is h centimeter. So what will be its area? Therefore total area of the open box is open, therefore area of the open box is area of the base, which is square with side x, is equal to x square plus 4 times area of the surfaces, 4 surfaces, that is 4 times length x, height h. So area of that surface, length into breadth, that is x into h. This is the total area, and it is given. How much it is? It is 192 square centimeter. This area is already given to us. This one. Okay. So this area is equal to 192 square centimeter. Therefore, x square plus 4xh is equal to 192. Remember, this is not our function. Our function will be volume of that box. What we have to find? Maximum. We have to find maximum volume. Therefore, that will be our function. Volume of the box will be our function. Here we have considered the area. Area is already given. Why we considered it? Because there are 2 unknown terms. Which are those? X and h. So we will convert this h in terms of x or x in terms of h. Okay. So let us convert this h in terms of x. What it will be? Therefore, h is equal to, look here, 192 minus this x square and is divided by 4 times x. Is divided by 4 times x. You can write this as this is equal to 192 upon 4 times x, dividing by 4, separating this denominator for the 2 terms. You will get here 4 4s are 16, 4 8s are 32 upon x minus x square upon 4x, that is x upon 4. This is our h. Okay, and now consider, you may keep this h as like this, or you may write this by simplified form. Now we will consider the actual function. So volume. Now volume of the box. What is the formula for volume of the box? If x length and breadth and h be the height, so volume of that box will be x into h, that is equals to x square into h. This is nothing but volume of the box, and this is our function. We will substitute this h is equal to this one. Substitute the value of h. You may take this one, you may take this one also. No problem. So our function, this h will be converted. Therefore, here only write the value of h so that it will be quite easy. This is equal to, I will write here, x square into bracket 48 upon x minus x upon 4. Okay, this is our function. Therefore the function is, so let f of x is equal to volume of the box, that is equals to, yes, and therefore f of x is equal to x square into bracket 48 upon x minus x upon 4 multiply by this x square, 48 upon x minus x upon 4, multiplying this we get, this is equal to x square into this one, x will get cancelled, so 48x minus x into x square, so 1 by 4 times x cube will be there. Okay, so this is your function, and now the process is same. Find first order derivative, then find second order derivative, then f dash of x is equal to 0, and then maxima or minima. So differentiate this with respect to x. Our function f is of x, so differentiate with respect to x. Differentiating this with respect to x, we get f dash of x is equal to 48x, derivative of 48x is 48, derivative of x is 1, minus 1 by 4 coefficient into derivative of x cube is 3x square. This is first order derivative. So this is equal to 48 minus this 3 is constant, so 3 by 4 x square. Again differentiate this with respect to x. Again differentiate with respect to x. So what will you get? Here again you will get f double dash of x is equal to, now look at this 48 is constant, so its derivative will be 0, minus 3 by 4 times coefficient constant, derivative of x square is 2x, so 2 4 get reduced and this will be minus 3 by 2 times x. This is our f double dash of x. Now for turning point for maximum or minimum value, we know that f dash of x is equal to 0. Now same process is there. Now f dash of x is equal to 0. Remember, every time for every example the process is same. It is only important to find the proper function. If you can find the proper function, then the next process you can do properly, no problem. So f dash of x is equal to 0. That is what is our f dash of x? 48 minus 3 by 4 times x square is equal to 0. Therefore you will get x square is equal to 48 into 4 upon 3, and that is equals to, yes, 16 into 4, 3, reduce this 48 by 3, 48 divided by 3, 16 3s are 48 into 4, so it is 64. X square is equal to 64, and therefore x is equal to 8. X is equal to 8. The dimensions are in centimeter, so x is equal to 8 centimeter. I have not taken that negative sign. X is equal to plus or minus 8 will be there, but remember what is our x? X is nothing but dimension. It is length of the base of the box. Therefore length will be always positive. Length will be always positive. If some length is there, it should be positive. It will not 0 also. I am not saying non-negative. It is positive only. So length is positive and hence x is equal to 8 centimeter. I got x is equal to 8 centimeter. I will put this value in f double dash of x, and then I will find is it maximum or not. So put this value of x is equal to 8 in the double derivative, that is second order derivative of f. Put x is equal to 8 in f double dash of x. Therefore f double dash of x is equal to f double dash of 8, and that is equals to, look here, the function is f double dash of x is minus 3 by 2 times x. This is second order derivative. This one is second order derivative here. Therefore substituting the value minus 3 by 2 into x is equal to 8. So this is equal to 2 4s are 8, 4 into minus 3, that is equals to minus 12, and which is less than 0. Which is less than 0, negative. And hence by second order derivative test, yes, x is equal to 8 is maxima. So that volume of that box will be maximum, is maxima, and maximum volume if it is asked, and maximum volume is equal to what is the function for volume? F of x, volume, is equal to 48 times x. X means 8 minus 1 by 4 times x cube, that is 8 cube. This will be the volume. You can find this after simplifying. I have to find the dimensions of the box. What is the question? Remember, dimensions to have maximum value. So I have to find the values of x and h, height. X is already obtained. What is x? X is equal to 8. Therefore, the dimensions of that box are x is equal to 8 centimeter, breadth 8 centimeter, and height h is equal to, what was the function for height? काय फंक्शन मिळालं होतं आपल्याला हाईट साठी? आय थिंक इट वॉज 192 minus x square upon 4x, right? So therefore h is equal to 192 minus 8 square, that is 64, upon 4 into x, that is 4 into 8, 32. So this is equal to the subtraction 198 minus 64, 4 plus 8, 12, 7, 12 upon 32. Yes, 128 upon 32, and therefore h is equal to, what is value of h? I will write it here. Therefore h is equal to, divide by 32 or reduce. By reducing it you will get 8 4s are 8 1s, 8 4s, 8 6 are, and again divide by 4. So 4 centimeter. So what are the dimensions? 8 centimeter, 8 centimeter and 4 centimeter. These are the dimensions. Height is equal to 4 centimeter and the sides are 8 centimeter and 8 centimeters of the base. So this is value of h, so that volume of that box will be maximum. Let us revise it again. Here area of the box is given 192 square centimeter. We used the formula. So area of the base x square and area of the four sides 4 times x into h. Then by using that we find h. H in terms of x is equal to 192 minus x square upon 4x. After that we find the volume. The formula for volume of the box is length into breadth into height. So x into h, x square into h, that is our function. Then we put value of h is this one. This is our f of x. Then process is same. Our steps: first step differentiation, first order derivative. Second step second order derivative. Then third step compare the first order derivative to 0, which is turning point. X is equal to, here we get 8, and then by substituting x is equal to 8, f double dash of x will be negative. We got here negative value which is less than 0. So by second order derivative test, volume is maximum, and for this the maximum volume, here you will find this is for you. For maximum volume we will get the dimensions x, h. This is your answer. 8 centimeter, 8 centimeter and 4 centimeter will be the dimensions of that box, so that you will have maximum volume. Got it?